Ok, pessoal, boa tarde. Hoje a gente tem então mais o último seminário, né, do ano aí para vocês. Vou speak in Portuguese, so they will understand English.
I hope so.
Yes. Então, esse aqui, como está escrito aqui, professor David Chadwick, né, vai falar sobre federações de identidade na nuvem. Eu espero que seja bastante interessante e que seja também muito útil para alguns de vocês, se não para todos, pelo menos para alguns de vocês. Tá? David é professor lá da Universidade de Kent, tá? Onde eu fiz doutorado, não foi com ele, mas ele já está lá há algum tempo, é professor titular da Universidade de Kent, tá? E vem participando, circulou por vocês também o resumo, né? O CV dele, o mini CV dele, né? Fez bastante coisa, espero que vocês tenham lido, porque eu não me lembro mais o que ele fez, mas ele tem participado de várias iniciativas por aí afora, inclusive de padronização. Então ele tem muito conhecimento nessa área aqui que ele vai falar para a gente, e aí eu espero de novo que seja bastante útil para todo mundo.
Okay, thank you. Okay, put your hands up if you have more than 10 passwords. Who has more than 10 passwords? Come on. Okay, more than 10. More than 10. Okay, more than 100. Who has more than 100? Nobody? I have more than 500 passwords. Yeah? I have more than 500 passwords. I can't believe that you just say you have 10. I mean, every website you go to, you have to have a new username and password. Do you use the same password on every site? Oh, obviously not interested in security. No, obviously not interested in security. Anyway, Federated Identity Management is meant to allow you to have one account with one very strong password. So maybe 15 characters that you can remember, one strong password, and then you can access hundreds of websites using the same username and password. That's the idea. So you can get rid of 10 passwords, you can get rid of 100 passwords, you can get rid of 500 passwords. We're not there yet, but we're moving to it slowly. So we're going to look at Federated Identity Management, some of the protocols that have been used, and then we'll look at OpenStack cloud computing and how we've integrated it into cloud. And at the conference we're going to give next month, we'll show how you can use your Google account to access OpenStack clouds. We were hoping to have the demo today, but it's not quite ready. Okay, so Microsoft Passport, this was invented nearly 20 years ago. The idea was to allow you to have one username and password stored at Microsoft's Passport site, and then you could access many different websites. And many companies joined the system, and they allowed you to log into their sites using your Microsoft Passport. It's called a passport, so you could go to all these sites. So how did it work? Well, you're sat there and you go to the first site and you see a sign in and the Microsoft Passport logo, and that redirects you to the passport site, and that's where your username and password are stored. And you log in to the passport site using your very strong password, the only one you ever should need. Okay? And you get redirected back to the site. They tell the site you've logged in, they tell the site who you are, and then you get access to the site. And when you go to the next site, okay, you click on the sign-in logo, and now the protocol just goes backwards and forwards. You don't notice anything, but you instantly get access to the second site. Now, what did Passport store? It stored your email address, it stored your password, and then you could also say what your birth date was, your country, first name, and all this other information, and then that information will be given to the site. So you need to just store your information once, and then share it with all the sites. Okay, and they sort of gave some privacy protection because they allowed you to say, well, I'll share my email address, or I'll share my first and last names, or I'll share everything. Okay, so it's not very good on privacy protection, but there was something there. But it failed. Okay, so why did Passport fail? Well, first of all, there are many reasons, and we'll look at them in more detail in a minute. But every site had to trust Microsoft. They had to trust Microsoft to hold your username and password and to participate. Now, if I am booking a car hire on the internet, why should Microsoft be involved? Why should Microsoft know about that? Okay, if I'm going to Amazon to buy a book, why should Microsoft be involved? So So that's one of the big problems, isn't it? You have to trust Microsoft. And Microsoft really, you don't want Microsoft involved in what you're doing on the internet. So that was one of the problems. So Kim Cameron, who was Microsoft's identity architect, he tried to think about why it all failed. He drew up these laws of identity to say what was wrong with this system. And first of all, user control and consent. The user should be able to control what attributes of his identity go to the website. Now, we saw Passport only gave you very limited control and consent. You could say my email address, or all of these things. You couldn't really control what was given to the site, so it failed on the control and consent. Minimal disclosure, again, it didn't do minimum disclosure, it was either email address or this whole bunch of things. So it wasn't allowing you to give just what the site needed. This is recorded in the data protection legislation that we have in Europe, where they say that there should be limitation disclosure. You should only disclose what is needed for the website and nothing more. So he was agreeing with the data protection legislation when he issued those two laws. Justifying the parties. The parties who were involved in the transaction should be there for a reason. And Microsoft clearly were not there for a reason. Well, they were there for a reason because they were holding your username and password, but you couldn't really say they were justifiable in that particular case. And then directed identity is saying that when I log into a site, I shouldn't be giving my same identifier to each site, which was my email address in Microsoft's case. So I give my same identity to each site. These sites can collude and learn more about me because I've got a globally unique identifier I'm giving everywhere. So he's saying you should really have a separate identifier at each site. So if the sites want to try and collude to find more about you, they can't, because you're known by 1, 2, 3 at one site, you're known by 4, 5, 6 at another site, and they can't say David Chadwick because they don't know it's David Chadwick. Got some unique identifier. But websites should have these omnidirectional identifiers. They should be publicly accessible. Everybody knows Amazon is Amazon and Google's Google. They should be, websites should have these omnidirectional ones. So he said they're different. Websites that are publicly accessible should have a globally unique identifier that everybody knows, but people should have these sort of private identifiers. Pluralism of operating technologies. In other words, there should be a competition, there should be many people can participate, which means we have to base it on standards. Microsoft Passport was their own proprietary system. It was based on Kerberos, but it was nevertheless proprietary to them. So that doesn't really allow other people to compete, because if you build your system to conform to Microsoft standards, and then Microsoft change it, you have to change your system. So it's not good for competition, so it failed on that one. Human integration. You should consider the human in there. You don't want the human to be easily attacked. You want to make sure that you protect the human in that from protection. But it didn't protect the human because if you go to a website that's an evil website and you say, I want to log in, they don't redirect you to Microsoft Passport. They redirect you to their own evil site that looks like Microsoft Passport. And then what do? You give this evil site your username and password, and then you've been phished. So it didn't protect against these sort of attacks, so it failed in that respect. And a consistent experience across context, that's saying when you go to multiple sites to log in, you should have the same experience everywhere. But Microsoft allowed sites to tailor the interface to their own logos and their own design, so the user wouldn't even have the same experience when he went to different Passport sites. So those were the reasons he sort of generalised for the failure of Passport. So the next thing then is standardization. And we'll look at standardization. And the first one that really has been successful is SAML. So here's some terminology that's used. SP is the service provider. This is the site that you want to access. And this site is a relying party. It's trusting the identity provider, which is the site that has your identity attributes. In your particular case, the identity provider could very well be the university here, because you have an account at the university, it knows about you, and it could act as an identity provider. And that's in fact what happens in the UK. We've got 800 or more sites all linked together, and my university acts as my identity provider, and so I will log into my university and it will pass my attributes to the relying party to say who I am. And that's what we've built there. So we've got the service provider and the identity provider, and they all trust each other. So there's a trust relationship there when they federate together. They have to trust each other because my university has to trust the site it's giving my identity to, that it's not going to abuse my identity, and the site that I'm going to, the relying party or the service provider, has to trust that the university did the proper authentication and that it really is me. So there's trust relationships there. And then there's also another one called an attribute authority, which just provides attributes. And that is starting to become more important now, because we recognise that one identity provider, such as my university, doesn't know everything about me, doesn't have all my attributes. For example, it doesn't have my bank details, it doesn't have my driving details. There are lots of attributes it doesn't have, and therefore, if I'm going to book a car hire on the internet and it wants to know I've got a driving license, I might need to go to an identity provider like a driving authority to say that this person has a driving license and is entitled to drive. So SAML then, this is a standard that was produced by OASIS, by lots of companies cooperating together. It's based on XML data structures, so it's all XML messages that are passed between the relying party, the service provider and the identity provider. And it defined 3 types of statement or assertion that could be sent from the identity provider. There was the authentication assertion saying, I have authenticated this person, and here's the ID. An attribute assertion saying, this person has the following attributes. Might be an email address, might be a date of birth, or whatever. And then there was also in the first version an authorization decision station, but that got removed, so I'm not going to talk about that anymore, because that was removed from the later versions of the standard. So they devised the protocol where you can request an assertion and get an assertion back, and they standardized data to be so, but because it's an XML message, it could actually be sent in any sort of communication protocol. It doesn't have to be HTTP and so, but that's the one that most people use. So we've got the authentication request says, what assertions about authentication can you give me about this user? And the attribute query says, what attributes do you know about this user? What can you tell me about his identity? And so that's the SAML one. So if we look at how it works, it was implemented by Shibboleth. This was a consortium of Internet 2 in the US. They got together, and many other organisations participated, including the UK. They contributed funding, and they developed this open source software. You can buy it, get it from free of charge from the internet. Many people use the Shibboleth software, and it's an implementation of SAML version 1 and version 2. So how does it work? So the user goes to the website. Now, here's an interesting problem. In the passport case, when you go to the passport site, you click on the logo to log in, and the logo or the website knows that you're going to authenticate a passport, because there only is passport. It's the only identity provider in the ecosystem. So it redirects you to passport. But now, if we're in a large-scale environment, say Brazil, and you may have more than 100 universities here, and you go to the service provider and say, I want to log in, where do they send you to authenticate? Do they send you to UFPE? Do they send you to Sao Paulo? They don't want to send me to Kent. Okay? So there's a problem. So we've got what's called a discovery problem. How do we discover where the user is from in order to allow them to authenticate? So they invented a where you're from service. And the where you're from service, as I'll show you in a picture, lists the different identity providers, and the user chooses his identity provider, is redirected to the identity provider, and then authenticates the identity provider, and then the identity provider can pick up some attributes as well and send a SAML assertion which says, I've authenticated the person, and here are his attributes. And here is a picture of one of the original where you're from discovery services, where there was a clicking list. You could click there and the whole bunch of IDPs would be listed, or you could start the search by typing in Kent, and then it would pop up the ones that matched your search criteria. So that allows the site to discover where you're from. And it had good privacy protection. It obeyed Kim Cameron's law of directed identities. because the user's identity was private and he was identified by a transient ID or a persistent ID. A transient ID was the same user would get a different ID every time it logs in. So every time you go back to the same website, you get a different ID. So the website can't even tell it's you the second time round. You're different. Okay, so that's very good privacy protection. But if you wanted to have the same ID every time, you could have a persistent ID which was minted specifically for that site. So that site is told it's user 123, and that's it. Okay, and every time you go back, you're user 123. And if you go to a different site, you're user 456. Okay, and you get a different identity minted. So it was very good on a privacy protection like that. Okay. It also had an attribute release policy which allowed the home site to set which attributes to be released, again to give control and consent to the user for releasing his attributes. So it was good on privacy protection, but it has some limitations. You can't dynamically, the website can't dynamically request a set of attributes. It's statically configured in. That's one of the failings. It has to have this predefined metadata to say which attributes are going to be released, which is not very good. It's open to phishing attacks, just like Passport. How? Well, you go to an evil website, and that pops up a where you're from service, which you think you recognise, and when you click on your university, it redirects you to a mirror site that looks like your university but isn't your university, and you enter your username and password again. And so you've been phished and you've lost your credentials. So it's open to phishing, which is not very good. It's also uses bearer credentials. So these SAML assertions which say who you are and how you've been authenticated are just tokens that are passed into your browser and then passed on. If anybody gets hold of that, they can use it because it's not linked to you. It's a bearer credential. It means that anybody who's got it can use it. Like cash in your pocket is a bearer credential. If I take your cash, I can use it. Okay? If I take your credit card, I can't use it because that's not a bearer credential. That has authentication information on it. So that's another weakness in the SAML. Okay, Microsoft Active Directory Federation Services. This is actually an implementation of SAML as well as other protocols, so I'm not going to go into here. And it uses a back-end Active Directory for storing your information. So you can see it works in exactly the same way as the previous protocols. You go with your web browser to a website, which is supporting this. It redirects you to AWS2, where you authenticate. It then goes to Active Directory, picks up your information and posts it back to the website. And it actually interworks more or less with the SAML tool and Shibboleth. So there Microsoft have bought into this, and that actually became a sort of replacement for Passport, using now standard protocols so that Microsoft could actually be an identity provider amongst its own group of sites. So you'd have one Microsoft identity, which they call Live ID, and you could use that then to log into many different Microsoft services. Now the latest protocol that's come out is called OAuth v2. Now this started off not as an identity protocol, but as a delegation of authority protocol. It was allowing you to delegate authority to another site to access your information. And one of the examples they gave was, I've got photos on a website and I want to go to another website to print my photos out like Photoshop, and I need to give access to the printing site to access my photos. And so it's my information and I want to delegate authority to another website to access my information. So that's how OAuth was devised. It wasn't for identity management. It was to allow one website to access your information on another website by delegating authority. Okay? And it works by having what's called an authorization server, where the website gets approval to access your resources. There's the resource server where your photos are stored, okay, and then there's the client of the site that wants to access your services. So here we've got the entities. This is the website that you want to give access to, and it's got this client application running on the website that's going to access your information. This is where your photos are stored, okay, and this is your authorization server, and this is you. And there's these trust relationships again between these entities. So what happens now is the website that wants to access your information requests you to have access, and it's a redirect via the authorization server, and you then say, yep, okay, I will grant this website access to my information. Now the client has got a grant from you, it gives the grant to your authorization server, and the authorization server turns the grant into an access token, and the access token allows you to access the protected resource. But this is usually a short-lived bearer token, so again we've got a bit of a weakness here because it's a bearer token. And when it's expired you can get a refresh token as well. But nevertheless, this allows the website to then go and access your resources, like your photos, and get them. Now after this was devised, people thought, actually, we could use this for identity management. How? Well, what if the information that's stored here is not photos, but it's my identity? Okay? What if what's stored here is my name and email address and all my other identity attributes? Then this could become an identity provider, and this is the service provider, and when I want to access this web server now, I could go to access it, and I would delegate authority to it to access my identity attributes. When it gets my identity attributes, it would then say, I know who you are, I will let you access my resources. So it's an interesting use of the case where the information that is being accessed is not your photos or other things now, but it's your identity. So this is showing how authorization worked for a website being, it's just a repeat of the previous pictures. When the user goes to the website, it's redirected, it authenticates, it gives a token to the site then uses it to access the resources and gives you access. Now, the problem with the OAuth protocol as it's specified in the IETF standard is if you want to use it as an identity provider, there are many features that are unstandardized. So the shapes of the tokens and the actual flow of the first message and the end messages. So there's a new standard called OpenID Connect, and that fills in the missing bits of OAuth. It says how you can use OAuth 2 to really act as an identity provider and to give login. OpenID Connect, so it uses the OAuth protocol, but it defines more tokens that are going to be passed and defines the exact format of the messages so that we can get into working in an identity provider way. And if you can get the specification, you can download it from here. So, let's look now where we've got our identity provider, we've got our service provider. So now in this case, I want to access this resource here. I'm going to use the identity provider, which is now an OAuth server. And what I'm going to do is I'm going to delegate authority for this service provider to access my identity attributes to give me access. So from a user experience, it looks very similar to SAML. The user's still the same parties involved, but the protocol's very different. But from a user experience, it looks the same. You can't really tell the difference between logging in with OAuth and logging in with SAML. Except with OAuth there's a dialogue which says, do you really want to give this person access to your attributes? And you don't actually get that in SAML. So the user goes to the service provider and says, I would like to log in, please. And the service provider then redirects the user to the identity provider and says, I want access tokens to get his identity information, his authentication information. And so the user has to authenticate now to his authorization server and authorize the client. The token then comes back, and that token comes back, allows the user to get access to the information. And once he's got access to your identity information, he can then give you access to the service side. So the difference now, the way the identity attributes are coming, if we just go back a step, you see the identity attributes are actually going through the back end, this server talking to this server, whereas in the SAML case, the identity attributes were actually going in an assertion that was coming around that way. So that's the difference, is that you've got a token that goes in the front end, but the actual identity attributes are going in the back end. Okay, so now on to cloud then. So given that clouds are the up and coming services, everybody's moving everything to the cloud, how can we access cloud resources using Federated Identity Management? Because those people who've used cloud, you'll find that most of the cloud systems will say, register for a new username and password. Okay, you get the cloud system and you get yet another username and password. Well, we said we would like to be able to access clouds using Federated Identity Management. Now, OpenStack is the most popular open source cloud software, but when we started to use it, there was no Federated Identity Management in it. It's made up of a set of services, and Keystone is their identity service. So it did actually have an identity service in it, but it operated like Kerberos. So your username and password was stored here, and then you would authenticate to here, and then like Kerberos, you get a token which gives you access to the other services. So, it's based on Kerberos. The user logs into Keystone, his password is stored in Keystone, he gets an unscoped token back, which is like a Kerberos ticket granting ticket. For people who are familiar with Kerberos, when you log in and send your password, you get a ticket granting ticket, and you send the ticket granting ticket to a ticket granting server who gives you a service ticket. And this one, you get the unscoped token, the list of projects, and then you swap it for a scope token, which is like a Kerberos service ticket. And then you pass the scope token to the service, and that gives you access to the service. And so your unscoped token gives you access, potential to all services on all projects, and you choose which one you want, and then get the scope token for the project that you've chosen. And the user is granted access then based on the information that's provided in the token. Now, usually it's based on role-based access control, a sort of role-based access control, meaning that you assign roles in projects in Keystone, and then each of the OpenStack services assigns privileges to roles. So Keystone gives you roles in projects, and the services give you privileges assigned to roles. So you log in, you get the roles, you then give your roles to the service, and the service says, with these roles you're entitled to do the following. Okay, so here it's saying, in order to list the services, you need to be an administrator, you need to have the administrator role. Okay, that's one of the policy statements that's in Keystone. So, authentication in OpenStack, the user authenticates to Keystone, sends his username and password, gets back the unscoped token, decides which project he wants to work on, gets the scope token, gives a scope token to one of the cloud services, and he's in. And you can see that that is very similar conceptually to federated authentication, where you authenticate to your identity provider, you get some sort of token back, you give the token to the service provider, and the service provider either has your information in the token if it's SAML, or it uses a backend to collect the information if it's OAuth. It now has your identity and it gives you access. So you can see that Keystone and OpenStack were already set up, almost they were dying to be federated, weren't they? Because they're already organised that way. So all you need to do was to combine the two together, where the user authenticates to the identity provider, gets back the token which he gives to Keystone. Keystone's now got a SAML token or OAuth token, and it then maps it into a Keystone token, gives the user the Keystone token, which then allows the user to access the services. So the key thing here is actually this mapping, because we're getting some sort of token from a federated protocol, but we need to map it into the tokens that services understand. If you give your SAML token to a Keystone service, it won't be able to do anything with it. It expects you to be a role in a project, and it expects to have a scope token. So there has to be some mapping. So that's a key component of the federated infrastructure. So it requires an Apache front end. So because the Apache front end does all the protocol handling, you have a plugin for the particular protocol, SHIP, Model IDC, OpenID Connect, or whatever. You plug that into Apache that does the protocol handling. It turns your attributes from your identity provider into environmental variables and passes those over to Keystone, and then Keystone uses its mapping rules to convert your identity attributes into roles in projects via either groups or users. So you end up being a set of roles in projects, and then you can use that to access the services. So as I said, the key thing here is this mapping which does this role. We'll have a look at what that looks like. So the mapping rule is quite complex because It has to be very flexible. It has to cater for any sort of identity attribute you can get from any sort of identity provider, and always map them into these roles and projects. So there are 5 different types of identity mapping rule. We can have an empty rule which says that we're not going to say what values are mapped. You're going to take the value that comes in and you're going to use it as is, okay? But you'll just map the attribute type. We've got an any one-off match where we say if your value of an attribute that comes in is any one of these, then you can map into a role in a particular project. We've got not any of, saying if you come in and you don't have any of these attributes, then you can be mapped, but if you have them, you can't be. Okay, and we've got blacklists and whitelists, which say if you've got values in this whitelist, they'll all be mapped. If you've got values in the blacklist, they won't be mapped. Okay, so I'll just give you one example here. This is an any one-off mapping rule. So this is what it looks like. It's written in JSON. That's the way OpenStack uses all its data structure in JSON. So this is mapping into the local group of contractors in the domain ABC1234. So any user who comes in will be mapped into this particular group of contractors. So what their attributes that they get from the identity provider will map them into the contractors group. Now here is the remote attribute. It's saying the attribute of organizational person type that comes from the identity provider. If it's got a value that contains contractor as a regular expression matching, if it has a string contractor, then it will be put into the group of contractors. And those contractors have already been given a set of roles on projects. So now, whatever you come in with the organizational person type from your identity provider will be mapped into the contractors group. And of course, you can see now, once you start to understand what attributes your identity providers are providing, you can alter your mapping rules accordingly to say, and people from different identity providers that have different attributes can still be put into the contractors group with a different mapping rule. So we can map users from different universities with different attributes, and we can still put them in the contractors group by having a different mapping rule for a different identity provider. So the core release then, when you get it, you have to say who your trusted identity providers are. Which identity providers in the world do we trust to authenticate people? Because remember, federation is based on trust. So we have to say who we trust. You configure all your mapping rules for different identity providers, and then you link them together with a protocol. You say, this identity provider with this protocol and this mapping rule. And then you can do it for each identity provider. That sounded good on the surface because you can do a tailored rule for every identity provider. But actually, in the UK Academic Federation, when we've got, say, 200 identity providers, and they're all providing the same attributes, we don't want to have 200 things configured in when we can just have one set of mapping rules for all 200, because they're all releasing the same set of standard attributes. So it actually was not a good design for large federations where all the identity providers are issuing the same sets of attributes. Yeah? So that's now been fixed. And we'll look at how that's fixed in the next slide. So, initially, in the original design, each trusted identity provider had an ID, and the ID was what was passed in the environmental variables. So you could check, okay, the identifier's got this ID, he's the trusted one. What they did was they said, we will make an identity provider have a whole set of IDs. So your identity provider effectively becomes a federation. And each of the IDs are the IDs of the identity providers in the federation. So we can now say, okay, for a trusted identity provider, it's no longer identified, it's actually a federation. For the trusted federation called Eduroam, we have all these different IDs, University X, University Y, University Z, etc. So whichever university you authenticate with, that will be carried in the environmental parameters, and they can still check that you've been authenticated with a trusted identity provider from this particular federation. So that's the way it was solved, large federations using the same mapping rules. WebSSO was also added to allow, because Horizon is a front end for OpenStack, which is a GUI, which allows you to access OpenStack via a browser. But it was no good the way it worked with the giving the unscoped token back, because basically it didn't actually work, because the user was on his browser and you couldn't give the unscoped token to the user because he wanted to get back to Horizon, but he couldn't because he just got a reply with an unscoped token in it. So what they've done is they've actually issued JavaScript. So what comes back to the browser now after it's authenticated is JavaScript, which actually redirects him back to Horizon, and now he's back in with his session with Horizon, he's logged in. So this was the Web SSO addition that was added in subsequent versions of OpenStack. Now there are still some outstanding issues. Federation is still not fully completed in OpenStack. We'll look at some of the issues that are still to be done. How do you dynamically get a list of accessible IDPs? We said we configure OpenStack with all our trusted IDPs. This is the discovery issue. I come to OpenStack, I want to log in, I need to see which are the trusted IDPs, because then I can say that's my IDP, I want to go there to log in. But unfortunately, that list of IDPs is not accessible. You have to be logged in order to read it. So that's no good for someone who's coming to log in. He says, what are your trusted IDPs? Well, we can't tell you until you've logged in. But I can't log in until I know which trusted IDPs you've got, so I can choose one. Yeah, so the fix at the moment, the way we fixed it actually, was we removed the protection from the call to trusted IDP, so you could actually make it publicly accessible. But the Keystone group didn't like that, because they said in some environments it shouldn't be publicly accessible, so we can't remove the protection from it. So what they've done at the moment is they've made you have to build into Horizon a duplicate list of all your trusted IDPs. So you've got it configured in Keystone, you have to configure it in Horizon as well as a static list, and then Horizon reads in this static list and displays that to the user, which is not a very sensible solution. So there is actually a proposal to do what's called a trusted set of IDPs, and that will be, I'll show that in the next slide in a minute. Another piece that was outstanding is still not in the existing code, is how to do these mapping rules. We said the mapping rules are very complex. They're JSON structures. You can't expect normal OpenStack administrators to be writing complex JSON mapping rules. It's a complex thing to do. And getting the syntax right, etc., getting the understanding. So one of my students last year, he actually produced a nice GUI, very intuitive, drop-down menus, you say what the things are, and that's now in the process of being incorporated into core release, been taken by the people put in there. Another issue is that when these federated users come in, they're not actually real users, they're just ephemeral users who are attached to a domain and they get the roles and privileges. Unfortunately, because they're not treated the same as permanent users, some things that work for permanent users don't actually work for federated users. So that is now a major issue to be fixed. Because you can't have, if I'm registered in Keystone as a permanent user, I get one sort of service, and if I'm logging via Federation, I get a different sort of service. That's not good. So they're now actually fixing that, and they expect it to be released by April 16. So if you come in as a federated user, you'll get exactly the same service as if you're a registered user. And then the final thing is, if I am a federated user and I come in and I log in, that's great, I'm now logged in, but what resources do I have? What VMs do I have? What files do I have? How can we dynamically give them to users who are logging in? That is still an outstanding issue. There is a solution which I'll come to, but it's not part of the core release. So we've talked about trusted IDPs, what the underlying problem was, and that we fixed it. There is now work to have a public and a private list of IDPs. So that's ongoing, so that eventually there will be a call in OpenStack where you can say, give me the public IDPs, and then you can dynamically configure that in Horizon. Dynamically creating OpenStack resources. This was done under the Giant GM4 project by the Hungarian Academy of Sciences, and they've developed a little set of scripts called a red site, and this plugs into mod shibboleth in Apache. So when the user comes into Apache and authenticates via shibboleth, it then calls this red site, and what red site does is it creates a user. It actually dynamically calls Keystone APIs and creates a user in Keystone. So now we've got you've come in via Federation, you didn't exist, you're not an ephemeral user, it actually creates you as a physical user entry. And then, when you log in, you now are that user registered in the database. It works. The problem is, though, they're never deleted. So all the federated users that come in, a new account's created for them, and they just grow and grow and grow. So there's nothing that actually deletes them. And once they're created, their privileges can't be altered. So if your privileges at your IDP change and your identity attributes change, nothing can be done about it because you've already been created in OpenStack with your project, and there's no mechanism to dynamically change your entry. So you get the privileges on first login, and you will have them forever. So if you get promoted, hard lines, you still have your lower privileges. If you get demoted, okay, you've got the higher privileges. But it's not just, so there's still some problems with that. Okay, so I think we're just about nice timing, yeah?